This video demonstrates a system that assigns internal textures to a surface mesh. It is used to synthesize a 2D cross-sectional image using reference images when the user cuts the model. First, we will demonstrate the browsing interface. The user cuts the model by drawing a free-form stroke. A new cross-sectional image is synthesized each time. The system first loads a closed triangular mesh. The interior of the mesh can be divided into several regions. Then the user cuts the mesh, which is divided into several regions. When the user clicks on a region, a dialog box for choosing the texture type pops up. Here, the user chooses a layered texture. Then the user drags and drops a reference image. The two marks in the reference image specify the upper and lower bounds of the texture. Similarly, the user specifies the upper and lower bounds in the surface mesh. This completes the assignment. The user can cut the model at other places. The system supports three kinds of texture: isotropic, layered, and oriented textures. Isotropic textures have a uniform distribution across the 3D space. They are not dependent on position or orientation. To assign an isotropic texture, the user first drags and drops a reference image. Then the user selects a portion of the image by rubber banding. The selected region is transferred to the reference cube and cross-section. The reference cube visualizes the relationship between the 2D reference image and the 3D geometry. Layered textures vary in appearance according to the position in an axial or radial direction. The user draws two marks specifying the upper and lower bounds. The region between the strokes is transferred to the side faces of the reference cube. Then the user specifies the corresponding upper and lower bounds in the surface mesh. Clicking on the border selects a surface region, and drawing a stroke makes it a constraint. Oriented textures require a flow direction. The user first transfers an isotropic image to the top face of the reference cube by rubber banding. The system sweeps the top image and shows the result on the side of the cube. The user then draws arrows on the cross-section to specify the flow field. This example demonstrates how to create a model tooth using a system.